Okay, for this diagram, we need this pressure sensor, pressure switch on our pneumatic side. And then we need it connected to a pressure switch on our electrical side. We also have a proximity switch. This is a capacitor-based proximity switch that we need to add into the circuit. So by now, you should be able to connect a solenoid to a solenoid and electrical circuit and a coil to the coil switch. Now, as you've noticed, I have this _2 in all my names here because I've found that in the different projects, if I go to a different project and I'm using a variable here like K1 for this coil, K1, that same variable is available for me to use if I use the same project, just a different diagram. And so I started putting this 2 on here as this is the second exercise or the second problem. So solenoid 1 in the second problem and solenoid 2 in the second problem. And this helps me keep my variables straight. So first, let's add this pressure transmitter to the pneumatic side. So we want to go to our pneumatic library here, and we're going to look in the sensors. There it is. And we're going to go down, and you're going to see these pressure switches right here. Here's this. If you hover over it so you can see the picture, you can see that this is normally open. That's what we want. I'm going to put that in here, and we're going to name it according to the exercise here, PS1. So pressure sensor 1, and I'm going to put _2 for exercise 2. And then I'm going to flip it over to make it match the diagram. So I'll go to position, flip vertically, and then I can bring it over to my spot to connect it. Now that's black, I know it's connected. And then the text color here is black as well, so I know it's not connected to anything in my electrical circuit yet, but I am transmitting now a PS1-2 or _2 here for my electrical circuit. Now I'm going to receive that on the electrical side, electrical control IEC standard. And I want to come over here to sensor switches. And inside my sensor switches, I can find these are proximity is a normally open pressure switch. I bring that over here and put it in my diagram. Now it has a question mark because it needs to be connected. So I double click on it, I go to variable assignment. Here's that question mark. And I'm looking for my pressure switch -2. There, I double click on it and it's connected. I know it's connected because both of them are blue now. That means those two are connected. Now I'm missing in the second spot here is a sensor reference point for full retraction and this sensor switch. So let's look for that. Let's first put up the reference point that is the transmitter in this case. So pneumatics, and I can just type in reference. And then I know it's in pneumatics, so I'm gonna look through those tabs until I get what I want here. And then again, I'm gonna label it as pressure proximity. I'm gonna call it proximity 1 _2 for the second exercise. And I'm gonna zoom in here and I'm gonna put this diamond so it matches the full retraction position. Okay. Now that I have that labeled, it's transmitting. It is a black text until I get the right part here in the pneumatic and the electrical side. So I want a sensor in my electrical side. So let's go down here first to my electrical control. And I want a sensor switch. And I'm looking for a capacitive proximity switch. Now again, we have these two here. We have a PNP capacitive proximity switch and NPN capacitive proximity switch. So what that is I want to use the PNP here, and this means that I'm going to connect my output here that is going to be switched on and off to the 0-volt line. If I was to use the capacitive NPN, see the NPN at the beginning there, if I was to use that one, I would need to connect the other side of this coil actually to the 24-volt to make it work instead of the 0. I would delete this and I would come over here and attach to that end, and then it would work exactly the same. So again, I'm going to pull in the PNP capacitive proximity switch and connect it to my spot here, but again, it has a question mark. Now we need to connect it to this proximity location of full retraction. So I'm going to come up here and search for PX. There it is. Now here's that case where I'm using the variable PX1 as a transmitter in the first exercise. So I need to make sure I delineate the names here if I'm going to stay in the same project. And so I put that 2 on the end. I'm going to double click on it to assign it to the receiver there. Now it has PX1 and it should work. So let's simulate it. Now you'll see in this simulation here as I push this push button that the cylinder does not go very far. And that's because the pressure that is causing it to retract by this signal from this pressure detector is once the pressure builds up on the blank side of the cylinder enough to trigger this transmitter, it's going to connect this electrical side switch here and cause it to retract. So what we have to do is we have to go in and into our flow control. We have to change the flow that is going through by changing the internal diameter of the orifice. You can see the diagram here slightly, but the internal diameter is the small hole that allows air through that's adjustable. So we're going to set this to 2 millimeters. Let's double check that that got set, 2 millimeters. And then we're going to set this one on the right side to 4.5. Enter. And now when we simulate, we can push this push button. It extends all the way before that pressure is reached. That causes retraction.